the equation x equals to fx has one root. We are to verify by calculation that this root is between 1 and 1.5. Say x equals to fx, we can rearrange and write this as 0 equals fx minus x. So we can let g of x to be fx minus x. So g of x now is e to the 2x plus 1 all over e to the 2x minus 1 minus x. Now, if gx is fx minus 1, we just need to show that g of x has a 0 in between 1 and 1.5. This implies that x equals fx has one root between 1 and 1.5. To show that g of x has a 0 between 1 and 1.5, we evaluate g at 1. So we replace x with 1. We have e to the 2 plus 1 over e to the 2 minus 1 minus 1. And that would give us 0.313, which is positive. Now evaluate g at 1.5. We replace x with 1.5. We have e to the 3 plus 1 over e to the 3 minus 1 minus 1.5. That is negative 0.395, which is less than 0. So g at 1 is positive, g at 1.5 is negative. There must be a value of x in between 1 and 1.5 such that g of x is 0. From these two, we say that g of x has a 0 between 1 and 1.5. Hence, we say that x equals f of x has a root between 1 and 1.5. Part B, use an iterative formula based on the equation in part A to determine A, which is the root, correct to 2 decimal places. Each iteration is to 4 decimal places. From part A, we know that x is f of x, so this is 2x plus 1 over e to the 2x minus 1. So we can write this as x sub n plus 1. This is x sub n, and we can use that for our iteration. The 0 or the root of x equals fx is in between 1 and 1.5. So the first one, the value that we could use, we could either use 1 or 1.5. Well, so this is 0.395, sorry. So this is negative 0.395. That is, well, the smaller value, the value that is closer to 0 comes from x equals 1. So we can let x naught to be 1. And then we can find x sub 1. We replace x with 1. You have e to the 2 plus 1 over e to the 2 minus 1. And that is 1.3130. Then x sub 2, we replace the x with x sub 1. You have e to the 2 times 1.3130 plus 1 over e to the 2 times 1.3130 minus 1. And that is 1.1510 to 4 decimal. Well, we need to continue this until convergence. Then for x sub 3 here, we have e to the 2x sub 2. We use this value to replace x sub 2 plus 1 over e to the 2x sub 2 minus 1. So x sub 3 to 4 decimal is 1.2224. X sub 4 here, we continue the process and we find x sub 4 to be 1.1900. We need to continue this. We have not reached convergence. X sub 5 is 1.2040. So we are going to continue with x sub 6, which is 1.1978. To 2 decimal, this is 1.20 to 2 decimal places. And this is also 1.20 to 2 decimal places. We need the next one. So if it converges to 1.20 for 3 iterations, then we can stop. So x sub 1, x sub 7, the next one is 1.2005, which is 1.20 to 2 decimal places. From here, we can say that A is 1.20 to 2 decimals. Part C, we need to find f prime x. So fx here is e to the 2x plus 1 over e to the 2x minus 1. To find f prime x, we apply the quotient rule, hold the denominator, so we have e to the 2x minus 1. Differentiate the numerator. We need to apply the chain rule. We have e to the 2x, and then when we differentiate 2x, we get 2. So this is 2e to the 2x minus, now we hold the numerator, so we have e to the 2x plus 1. Differentiate the denominator, that is 2e to the 2x. And this is all over the square of the denominator. If you look at the numerator, you will see that you have 2e to the 2x, 2e to the 2x, which we can factor. So we factor 2e to the 2x. Then you are left with e to the 2x minus 1 minus, then we have e to the 2x plus 1. Denominator stays, so and we can simplify the numerator now. So we have 2e to the 2x, e to the 2x minus 1, minus e to the 2x minus 1. And this will give us -2. -2 times 2 here, that will be -4. E to the 2x in the numerator. So there is no change in the denominator. We have e to the 2x minus 1 squared. That will give us f prime x. Hence, we need to find the exact value of x for which f prime x is greater than 0. This is for the case where x is positive. So we set f prime x to be -8. So when f prime x is -8, -4 e to the 2x all over e to the 2x minus 1 squared. That is -8. We can cross multiply so that -4 e to the 2x is -8 times the square of e to the 2x minus 1. We can divide throughout by -4, so this -4 becomes a 1, that -8 becomes a 2. We have e to the 2x on the left, And we have 2 times the square of e to the 2x minus 1 squared. We can always let y to be e to the 2x. Then we have y equals 2 y minus 1 squared. We can now expand so that y is 2y squared minus 2y plus 1, and y is 2y squared minus 4y plus 2. Rearranging, move everything to one side so this can go over. We have 2y squared minus 5y plus 2 equals 0, which can be factored as that is a 2, that is a 1, negative, negative equals 0. So we have 2y minus 1, y minus 2. Now solving each of them, we solve for 2y minus 1 equals 0, so that y is 1 over 2. But y is e to the 2x. We need to find the value of x. So e to the 2x is 1 over 2. Taking log on both sides, we have 2x equals ln of 1 over 2. And 2x here is ln 1 over 2 is 2 to the 1. So that x is 1 over 2 ln 2 to the 1. 2 to the negative 1. And using the power law, x here is negative 1 over 2. Bring the negative in front, ln 2. And this is impossible. This is not the value of x that we want, because x must be positive from the question. X must be positive. Unfortunately, we have another root. We have y minus 2 for the other root. We set for y minus 2 to 0, so that y is 2. But y is e to the 2x, that equals 2. Taking log on both sides, we have 2x equals ln 2, and x equals 1 over 2 times ln 2. That is the solution that we want.